Hi, so in this video we're going to be delving into electricity. Let's start off by looking at some of the most basic properties of electricity, starting off with current. I'm sure all of you have heard of current. Current is measured in amps, just shown as A, and it is defined as the rate of flow of charge. Basically, how much charge is passing a point in the circuit per second. That is current. And then next up you have voltage. Voltage is measured in volts, which is shown as V, and it is the energy supplied per unit charge. Voltage is also known as potential difference. It's the same thing. PD. And then we have resistance. Resistance is measured in ohms, and it is represented by this omega, I think. Alright? And it is the measure of opposition to current flow in a circuit. Let's just write that. And it's basically what impedes the flow of current, and we can also define it using the equation, which we are gonna explore right now, right? So let's start off by drawing a circuit. Very, very basic circuit. Let's say you have a cell and you have a filament bulb. Now, how are you gonna measure current and voltage in the circuit? So how you measure voltage is what you basically do is you set up a voltmeter parallel to the filament bulb, and you set up an ammeter in series with the filament bulb. So that's the difference. You set up a voltmeter parallel to the filament bulb, and you set up an ammeter in series to the filament bulb. And the reason for this is what happens is basically the voltmeter has a very, very high resistance, because you don't want any of the current to enter the voltmeter, right? You just want current to flow through here. And now, since current comes at this junction, and if the resistance in the voltmeter is very high, the current is not going to take this path. The current will not take this path, but it will take this path instead. So that is why it's put in parallel, because if the resistance is so high, the electrons will choose to flow to the low resistance path, right? So that's why what the voltmeter does is essentially measures the voltage here and the difference between that, and it gives you a value for the voltage, and hence that's why it's called the potential difference, right? Because it gives you the difference in the reading of voltage between here and here. Basically, that shows you how much voltage has been transferred to the filament bulb, because you're looking at the voltage before and after. And then after that, you have the ammeter in series, and the ammeter, unlike the voltmeter, which has very high resistance, the ammeter has very, very low resistance. And the reason why it has very low resistance is so that it doesn't take up any voltage from the cell. Any component in the circuit that has resistance takes up voltage, right? And if the ammeter had a significant resistance, it would take up a significant proportion of the voltage, right? Which would end up lowering the entire current in the circuit, which you don't want to do, right? You want it to have very, very low resistance, so it's not taking up a significant proportion of the voltage, so that the proportion of voltage it's taking up is completely negligible. So you can just ignore the effect of the resistance in the ammeter, and by putting it in series, you can measure the current that's inside the circuit, right? Because you're putting the ammeter in series. So that's the reason why the ammeter is in series. So this essentially gives you a value for the voltage, and this gives you a value for the current. And now what you can do is, how will you calculate your resistance? So this is where the equation comes into play. You have this very common equation that is vital for electricity. V equals to IR, right? As we mentioned, V is so basically V is your voltage, I is your current, R is your resistance. Okay, and now what you can do is you can use the value you obtain for voltage from the voltmeter and use the value obtained for current from the ammeter to calculate the value for resistance by rearranging this equation, and you get V over I is equal to R. And what you can also do is plot a graph, right? Which is, they're commonly known as IV graphs. You plot an IV graph, current on your y-axis, voltage on your x-axis, and then you calculate the gradient, I divided by V, which is basically equal to 1 over R, right? So your gradient is the reciprocal of the resistance, and then after that you do 1 divided by your gradient, which is 1 over R, to give you the value for R. Or sometimes you just see VI graphs, and when you see a VI graph, what you just do is you just calculate the gradient, because V over I is equal to R, so there's no need to divide it by 1 because the gradient is not the reciprocal of the resistance, right? So that's basically what you need to know. Now let's go through a couple of important equations, right? So as we mentioned, we saw that current is the rate of flow of charge. So can we derive an equation from that? So basically it's the rate of flow of charge, right? And that's like saying, you know how so let me tell you. Rate of flow of charge, rate basically means per second, right? Rate of flow of charge means charge per second, right? So from there you can get this equation Q equals to IT, because Q over T, which is charge per second, is equal to I, right? You have rate of flow of charge per second, which is current. So this is where you get this very important equation from: Q, which is charge, I, which is current, T, which is time in seconds. This is what you need to know, right? And this is how you get the equation. And then we can also get an equation for voltage. So you have energy supplied per unit charge. So voltage is equal to energy per unit charge, which means voltage is equal to energy over charge. So then you can rearrange this to get E equals to QV, right? And this is where you get your second or third, technically, very important equation. Okay, now let's just take a deeper dive into series and parallel circuits. So there are basically two types of circuits. You have a series circuit and you have a parallel circuit. So a series circuit is basically, let me demonstrate this with 3 filament bulbs. So you have a cell, and then after that you have a filament bulb, you have another filament bulb, and you have another filament bulb. And since these are all next to each other, these are all in series. Now let me draw a parallel circuit. On the other hand, a parallel circuit is basically this, and this. So as you can see, the filament bulbs are parallel to each other, and in this, the filament bulbs are series to each other. So what is the difference between these two circuits? So basically, in this circuit, the voltage is split between these bulbs. So let's say all of these bulbs, filament bulbs, are identical, which means they have the same resistance. Okay, since all of these bulbs are identical, let's say we have 3 volts. Okay, for like mathematical simplification, let's just say the cell has 3 volts, and now what happens is each of these gets 1 volt because they're all identical, so they get the same share of the voltage, right? So one very important rule is in series voltage is divided between components based on resistance. Between components based on resistance. And the reason why all of these have 1 volt is because, like I mentioned, they all have the same resistance. But in a different scenario, let's say they all 3 of them have like different voltages, have different resistances. Let's say this has 2 ohms, this has 4 ohms, this has 6 ohms. So now what we'll do is, let's put a ratio. So you have basically 1 to 2 to 3. That is your ratio of resistance. Let's just label these ABC. ABC, that is your ratio for the resistances. Now what you have to do is you have to use that 3 volts and divide it, right? So you have 1 plus 2 plus 3, which is 6, right? And then you do 3 divided by 6, and then multiply that by 1, multiply that by 2. I'm basically multiplying 0.5. All right, and 0.5 times 3, which is 1.5, right? So this is basically the voltage each of them gets. So A gets 0.5, B gets 1, and C gets 1.5. And as you can see, right, as you can see, as the resistance doubles, the voltage you receive also doubles. So that basically means voltage and resistance are directly proportional. So the higher the resistance, the more voltage the component gets. So they are directly proportional. On the other hand, right, what you need to know is that current, when resistance increases, current basically decreases. So the higher let's say the resistance of this was automatically to go up to 5, right? Let's just say it went up to 5, and that means the current in the entire circuit has decreased. The current at each point in a series circuit is the same. It's the same everywhere. So if the resistance of one component increases, the entire current in the entire circuit will decrease. Now another thing, right, let's just to prove to you that the current is same everywhere, is 0.5 divided by 2, which is 0.25, and then you have 1 divided by 4, which is also 0.25, and then you have 1.5 divided by 6, which is also 0.25. So as you can see, in a series circuit, the current is the same everywhere, and the voltage is divided based upon the resistance of the components in series. Okay, those are the 2 most important things you need to know. And then after that, you have a parallel circuit. Parallel circuit is actually very different. So in a parallel circuit, what happens is, let's say you have, again, let's just go with 3 volts, and you have 3 volts, then, but it's not like 1 volt, 1 volt, 1 volt. This time, each branch, this is a branch, this is a branch, okay, and each of these branches gets the maximum voltage, which is 3 volts. So this also gets 3 volts, this also gets 3 volts, this also gets 3 volts. If you were to add another bulb, this would also get 3 volts. So when you put each branch that's in parallel gets the same maximum voltage. Okay, what about current? So in this scenario, let's just assume that each of these bulbs has the same resistances, and if they all have the same resistances, let's say you have 6 amps in the circuit, then through each junction, these are junctions, by the way, these are all junctions, and through each junction there'll be the same amount of current flowing through. So 2 amps will flow through this, 2 amps will flow through this, and 2 amps will flow through this. But that's not necessarily always the case, right? I'm just assuming that each of these filament bulbs have the same resistances, they're identical, so each of them will get the same current. But, right, if they're not identical, right, if they have different resistances, then they will get different amounts of current. So let's just say you have like 10 ohms over here, and you have like 3 ohms over here. Now what happens is, there's which junction do you think more current will flow through? More current will flow through this 3 ohms junction, because there's less resistance. Why would current choose to flow through the path with higher resistance? It's more difficult for it to get through, so it's going to flow through the low resistance path. You can imagine yourself, you're in a corridor and it's very crowded. You can imagine this as a crowded corridor, right? And this is not very crowded, right? It's spacious. And which one will you choose to go through? You're obviously going to choose to go through the spacious corridor. The same way current is going to choose to go through the junction or branch with lower resistance. That is why the current over here will be greater than the current over here. So as you can see, right, the voltage in each branch is constant. Let's write this down. Voltage in each branch, same, right? Voltage does not depend on resistance, right? You have like a 10 ohms in parallel circuits, at least you have a 10 ohms filament bulb, and you have 3 ohms filament bulb, but they're both getting 3 volts. The only thing that determines what voltage you're getting is the fact that it's in parallel. So anything you put in parallel, if you put like a 9 ohms filament bulb over here, that's also gonna get 3 volts. Okay, but what happens is current splits at the junction, right? Current splits at a junction and there is greater current in low resistance components, right? So it's splitting at the junction, and then it's gonna flow more current will flow through the low resistance filament bulbs, and less current will flow through the high resistance filament bulbs. Another thing you need to know is that basically, as you can see, current means that charge is being preserved, and voltage means that energy is being preserved. Okay, the fact that current is splitting at a junction means that overall in the circuit the current is still the same, right? When it meets let's say current is flowing from here to here, it's 6 amps, it splits up, right? I'm just giving random values. This gets 1, this gets 4, and whatever, and then after that when it comes back, it's still 6 amps. So that means that current has been preserved, and when current is preserved, charge is preserved. And if voltage is the same, right, voltage is the same, that means energy has been preserved. The fact that when you add voltage together and all of these, you still get 3 volts. 3 volts is the voltage in your battery, in your cell, so that means that energy has been preserved. So that's it.